A warm welcome to all. Today I am going to discuss about do's and don'ts in civil construction. The main reference is IS 456-2000. This is a very important subject and interesting too. Before I start with do's and don'ts, let me say something about the reinforcing bars being used in various structures to give due emphasis to good construction. What is an iron and a steel? How to identify the types of bars from their physical appearance. I have shown here two types of main bars. One is mild steel, which are having a smooth surface, whereas the other one is tar steel. They have got ribs. The term tar has come from this torque operated reinforcing bars, that is tar. Iron and steel. Iron, the strong magnetic silver grey metal. The element is Fe as per periodic table and its atomic number is 26. Then what is steel? The iron containing a little carbon, C, with or without other things, is known as steel. More the carbon, more the hardness, and hence becomes more brittle. Stainless steel. This is a form of steel containing chromium, that is an element which is resistant to tarnishing and rust. The tarnishing means loss of shining on exposure. That is why the stainless steel doesn't lose its shining and doesn't get rusted. Structural requirements of steel. Tensile strength. Mild steel has 250 newtons per mm square or megapascal. Tar steel has 415 newtons per mm square, 500, 550, 600 megapascal. Bond strength. Ribbed bars, that is tar steel, has 3 to 4 times more bond strength compared to round bars, that is MS bars. Ductility. Fe 415, 500, 550, 600 should have 15 to 12.5% elongation, which is required to have flexibility in bending of steel. Bendability. If the carbon content is less than 0.25, gives excellent bendability. Weldability. If carbon content is more than 0.25, generally unsuitable for welding, especially oxyacetylene welding, which is not recommended. Fatigue strength. Due to repeated loading, stress develops. So the steel should be strong enough to sustain that stress. Corrosion. Proper minimum cover to be given to avoid the corrosion in RCC structures. Cracks in RCC structures, if less than 0.1 to 0.2 mm, there will be no corrosion takes place, because the ingress of water and oxygen requires a little more thickness of cracks, which may lead to corrosion of steel. Fire resistance. Temperature, if it goes more than 500 to 600 degree centigrade, the steel reduces its tensile strength to 230 megapascal. That is how the WTO, which was planned to collapse, bombarding with a aeroplane by the Osama bin Laden. So when the plane hit that building, the temperature rose in terms of 1000 degrees centigrade, due to which the steel gets its tensile strength reduced and the building collapsed. Reinforcing bars classified as grades. Fe 415, TOR 40, TISCON 40, CTD 40, TMT 40. They are all TOR steels, but basically TOR operated reinforcement. TISCON is Tata Steel Company. CTD cold twisted bar, deformed bars. TMT thermomechanically treated. Similarly, they are available for FE 500, FE 550 and 550D. D stands for ductility. Conclusion: structural requirements of steel. FE 415, FE 500, FE 500D, FE 550, FE 600, ribbed or twisted bars satisfy all the structural design requirements for conventional structures. Let us understand about cement. Cement selection should be appropriate for the intended use. The first original cement was 33 grade OPC, that is ordinary Portland cement, conforming to Indian Standard 269. Similarly, 43, 53 grades. Rapid hardening Portland cement has IS 8041. Portland slag cement IS 455. Portland pozzolana cement, that is fly ash based. Portland pozzolana cement calcined clay based. Hydrophobic cement, low heat Portland cement, sulfate resisting Portland cement. We have to select the cement appropriately to use for the intended purpose. Do's and don'ts. Many times, though the RCC structures are properly designed, they may fail because of improper bar bending or improper methodology in construction. Therefore, this is an important aspect for all field engineers and fresh graduates and postgraduate students. Let us look at some basic aspects. The minimum cover to concrete, that is for general structures, reference is clause 25 of IS 456 2000. These are all minimum covers that are recommended. For slab 15 mm, walls 15 mm RCC walls, beams for main bars 25 mm or maximum diameter of the bar provided in the beam, stirrups in beams 15 mm, at the end of main bar 25 mm. For columns, if the column depth is up to 200 mm, that is 25 mm. Depth, if it is more than 200 mm, 40 mm or maximum diameter of the longitudinal bar provided in the columns. Ties in columns, for which 15 mm. So you can see here, slab 15 mm, for beam main bar 25, stirrups 15, but in common practice all over the section for beams 25 mm cover is given. At the end of beams, you can see right side 40 mm cover is given. For columns 40 mm all around. For RCC walls 15 mm minimum. The bars you can see here for RCC wall having two-layered reinforcement, the bars should be provided in staggered way, that is zigzag arrangement as shown in the drawing. Mats in footing on CC bed minimum cover 15 mm, on prepared earth 75 mm. For chemical industries, as the above mentioned cover, minimum cover should be added with 15 mm but should not be more than 75 mm. Water retaining structures as above, subject to minimum of 25 mm. Seashore structures as above plus 40 mm but should not be more than 75 mm as per IS 456. For easy way of adopting the covers, it is recommended to use readily available cover blocks. For concrete cover blocks, contact cement dealers. Nominal cover to meet durability requirements based on exposure conditions. For mild exposure, minimum 20 mm, moderate 30 mm, severe 45 mm, very severe 50 mm, extreme 75 mm, in no case more than 75 mm. Durability of concrete. Durable concrete is the one which performs satisfactorily in the working environment. Main factors influencing the durability is permeability to the ingress of water, oxygen, carbon dioxide, chloride, sulfate, etc. In addition to this, following factors also influence the durability. They are the environment, the cover embedded to steel, the type and quality of constituent materials, water cement ratio, refer table 5 of IS 456, workmanship to obtain full compaction and 100% curing, the shape and size of the member. Here I would like to emphasize on three factors. I call it as CQ theory, CCC. The first C is cover, second is compaction, third is curing. If these three C's are followed properly, you will get a very good concrete. Grades of concrete: final and coarse aggregate by mass per 50 kg of cement. One bag of cement weighs 50 kg. I hope all you know. Proportion of the fine and coarse aggregate, quantity of water per 50 kg, that is per bag of cement in liters. M5 800, M7.5 625 fine aggregate, M10 480 kg, M15 330, M20 250. Proportion of the fine and coarse aggregate, generally 1:2, but subjected to an upper limit of 1:1.5 and lower limit of 1:2.5. Quantity of water for M5 60 liters, M7.5 45, M10 34, M15 32, M20 30. For an average grading of fine aggregate, that is zone 2. These proportions shall be 1:1.5, 1:2, 1:1.5, 1:2.5. Proportion for nominal mix concrete have been explained. Note that for mixed design, refer lab values, not these values. Minimum and maximum reinforcement. Tension reinforcement, AST, follow the formula AST by BD equal to 0.85 divided by FY. Maximum is 0.04 BD. Compression steel, ASC, 33% of AST and 4% of BD. Beam side reinforcement. When the beam web is more than 750 mm, that beam is treated as deep beam, so side reinforcement has to be provided. The minimum side reinforcement should be 0.1% of web area and maximum which is to be designed. Spacing of stirrups, minimum 80 mm, maximum 0.75 if defective depth, or 450 mm, whichever is maximum. Slab main and distribution, that is 0.15% for MS and 0.12 for torsteel and maximum of 2%. Maximum and minimum diameter of bars. Minimum diameter to be provided is 8 mm main and 1/8 of total thickness of slab should be provided for maximum bar to be provided in slab, whereas in columns the minimum diameter of the bar should be 12 mm. Development length, that is LD of bars. It will be calculated using the following formula: LD equal to pi into sigma S divided by 4 tau CBD. It is tau C, T means. Phi is equal to nominal diameter of the bar, whereas sigma S is stress in bar at the section in design. Tau C into BD is design bond strength, stress given in table 26.2.1.1 of IS 456. Anchorage length of bars. The anchorage length of straight bars in compression shall be equal to the development length of the bars in compression. Development length LD of bars, that is for TOR 50, values are given in centimeter. I have made two sections, that is tension section and compression. Here the bar diameters are mentioned. You can refer this table to get LD for bars in tension and in compression. Anchorage length for M15, M20, M25. Tension, in case of tension, the anchorage length should be 50 times the diameter of the bar. For M20, 45 times the diameter of the bar. For M25, 40 times the diameter of the bar. As the concrete grade increases, the anchorage length gets reduced. For compression, for M15, 45 diameter. For M20, 40 dia. M25, 35 dia, where D is the diameter of the bar. Concrete mixing. Mixing shall be mixed in mechanical mixer. The mixer should comply with IS 1979 and IS 12119 and shall be fitted with water measuring or metering device. The mixing shall be continued until the mass is uniform in color and consistency is achieved. If there is segregation after unloading from the mixer, the concrete should be remixed. For guidance, the mixing time shall be at least 2 minutes. For hydrophobic fear of water, that is cement, it may be decided by the engineer in charge. Dosage of retarders, plasticizers and super plasticizers, if used, shall be restricted to 0.5, 1 and 2% based on the performance test and as recommended by the respective manufacturers. Do's and don'ts. I have classified do's and don'ts into two groups. One is do's and don'ts in bar bending schedule. The other do's and don'ts in construction. Let me start with do's and don'ts in bar bending schedule. You can see here I have shown columns and beams sections. Let us take beam section shown upper side. What is the mistake in that? The hooks left, they are only on single side. That should not be done. They must be alternately provided on both the sides, which is shown in the section shown below. For columns, again the hooks are shown only in opposite directions, in the same direction throughout the column, but it should not be like that. You can see the section shown below for column, whereas the hooks are provided, ties hooks are provided alternatively to all the corners. You can see in case of cantilever beam, the tension will be on top, compression will be at the bottom. The hooks provided in the first section on the left side below, they are shown in tension zone, that is on the upper side. Always hooks should not be left in tension zone. They must be in compression zone. That is why the right section shows the hooks provided, they are at the bottom, that is in compression zone. For staircase, you can see reinforcement. It is folded open staircase without waist slab. The first one shown reinforcement is not correct. The one which is shown below, it is correct. But for every corner I have shown 3 bars, but generally there will be provided another bar which is like a small lintel structure that will be provided. Technically speaking, that the 4th bar which is not shown is not required. However, for the ease of construction, they provide like lintel structure and they provide at every corner as shown in the here. You can see the reinforcement shown for staircase. The first one is wrong, second one is correct. The bars should be crossed as shown, and you must provide a concrete bed block in case of load bearing wall structures. You can see the RCC wall. For the corners, the bars should also cross each other and additional bars should be provided. The length of the bar extended should be equal to increased length as shown in the second section on the top. Similarly, for T-joint for RCC walls, the reinforcement shown in the first section is not correct, whereas the second section is showing the correct reinforcement. For slab, this is for one-way slab, whereas the main steel is provided at the top and distribution is provided below that, which is not correct. As the tension is at the bottom, the main bar should be provided at the bottom and the distribution bar should be provided above that, which is shown correctly in the second section shown below. Don't try to use 2 grades of steel in the same RCC section. This is shown for slab. In first section, TOR 40 and TOR 50, that is TOR 500 and TOR 415, which is generally called as TOR 40, they are used. But whereas in the second section, TOR 40, they are used, which is correct. Never mix up 2 grades of steel in the same section. Similarly, for cantilever slab, the tension bar is not extended in the first section, whereas the section shown below, the tension bar is extended up to 0.3 L as shown, which is correct. Similarly, for supports, in case of slab, the bar should be provided as shown in the section below, not as shown in the section above. For continuity of bars in columns, never lap the length of the bars in the same zone. They should not be lapped at the same place. There must be zigzag or staggered lapping should be there, which is technically correct. While construction joint is provided in a column, don't provide a sloping section of surface or the stepped surface as shown in the section's left side, but provide the section shown in the last section, that is rough surface and flat surface. Beams and columns joint, very important. Many times we see, since it will be complicated, space will not be sufficiently available to provide ties and stirrups at the junction. The people, they don't provide the ties or the stirrups in that junction, but this is very important. You should provide tie as well as stirrups in case of beam and column joints. If not possible to provide the full tie or stirrup, you can make U-shape two pieces and you can join them and tie them. Beam, abrupt kinking of bars in column. When you will be extending the column bars, there should not be sudden kinking. It should not be kinked in the short distance and extended further. You should start from the bottom of the beam and to the full width of the beam, the bar should be left in the sloping direction so that it can be extended for further section above. defective provision of ties in columns. So ties are not provided in the left section, whereas the ties of the column are provided in the right section, which is correct. Discontinuity of bars in columns. See the left section, what I have shown sections, the bars are not continued. They are simply bent and continued for columns in the upper floor, which is not correct. And if they are welded, they are not sufficiently welded, that is also wrong. Whereas in the right side sections I have shown the bar should be welded minimum 150 mm depth to be anchored to, and they should be bonded with the chemical, and recommended welding length should be provided to extend the bars in case if the bars are cut at the surface and no bars are left for extension. At that time you have to drill the hole, go to the previous bar provided in the lower column and weld with the new bar with the recommended weld length, and then extend the bars for further floors. Straightening of bars in future. Sometimes what happens, if the future development is there, the bars will be bent, and while extending they will be straightened, which is not correct. What you have to do, as shown in the right section, you should leave the bar for its development length and cover them with the brick bats or dummy column with waterproof to finish, and whenever you want to extend that column you dismantle that dummy column and extend the bars for the full development length and continue with the structure. Lap length. Lap length is generally not recommended for tension zone. They must be provided in compression. But if at all it is to be provided in tension zone, if it is an inevitable condition, then what you have to go, instead of LD you have to provide 2 LD, that is 2 times the development length. And for that development length, the stirrup should be closer, that is 1.5 times the usual spacing provided, and it should be minimum 85 mm and maximum spacing 100 mm. Curtailment of bars. Don't curtail the bars at the same point. They must be staggered as shown in the second section shown below. Footings are shown here. Nowadays these tapered footing are almost outdated. Flat footings we are going. In case of flat footing as well as sloped footing, the longitudinal bar should be bent for minimum of 300 mm as shown in the right side section, which is correct. But whereas the left side section, it is for a short distance, which is not correct. Now let us see do's and don'ts in construction. Buildings may fail because of defective construction. Therefore, it is very essential to know the do's and don'ts in construction also. The construction joint in slab. Sometimes the situation may be to extend the slab for the next day. That time, where to leave the concrete to extend it for the next day. It should be left either on the column with the stepped, or to a distance of x, which is x equal to 1/3 to 1/4 of the span. Up to there you have to extend the concrete and then leave the concrete to extend for the next day. The last two sections shown below, they are correct, whereas the above are not correct. Don't mix two grade of concrete in the similar sections, as no two grades of steels are permitted. Similarly, no two grades of concrete in the same section are permitted, never provided. You can see the construction joint at beam and column junction. The last one is correct, to extend the concrete for column and beam junction. The other three, they are not. Other four, they are not correct. The arrow mark indicates the direction of concrete to be extended. In case of footings, whether it is stepped or sloped, provide kicker or starter to provide formwork properly, and the surface of the kicker should be made rough, whether it is stepped or flat footing or sloped footing. Concreting in sloped slab or beam. In many cases we have seen, though the slab is totally sloped, even then we find dampness, leakages in the slab, though there is no space to for the stagnation of the water. Why it happens? Because the concreting will be done in a wrong way. You should never start the concreting, laying of concrete from the top towards the bottom. From both the sides, we have to start from the bottom towards the ridge point. Then the concrete will be properly compacted, it will be dense, and you can avoid the cracks. And the reinforcement shown, they should be as shown in the figure, just like the reinforcement provided for the slabs. Steps to be followed while and after concreting in sloped slab or beam. Centering should be strong enough with sufficient support, supported in opposite directions of the slope also. Horizontal ties should be provided for supports. Water cement ratio shall be maintained as recommended by the designer. Concreting shall be from the bottom towards the top, that is towards ridge, in horizontal strips of slab, width less than the length of the tampers. Ridge fillet shall be provided at the ridge portion. Immediately after concreting, slab shall be broomed with cement slurry and then shall be plastered with waterproof compound to cover the micro cracks developed due to shrinkage. On the very next day, early in the morning, again slab shall be broomed with cement slurry to patch up the micro cracks. Typical bar bending schedule for slab beam with fixed, continuous and simply supported end conditions is shown here. You can see the bar bending schedule which is recommended as per the standards. A typical expansion joint in final roof or slab is shown here. This has been designed by me so that we can avoid the leakages in expansion joint by providing this section, which is clearly explained. When both the slabs expand and contract, the lintel edge section shown above, it moves to and fro and allows for expansion and contraction, whereas the portion provided with thin tar felt or paper avoids the ingress of water into the joint. Similarly, for columns also we can provide like this. We can have a half cut PVC pipe and provided all along the depth of the column, whereas the upper portion shall be covered with movable cap so that the water will not ingress into the joint and the rusting and dampness can be avoided in the building. The bar bending schedule in sloped slab is shown. It is same as the simply supported slabs or continuous slabs, and that has been shown here. All these things shall be provided carefully while providing the reinforcement for slabs. Thank you.